Hi, everyone. Welcome to yet another installment of our Open Config and Open Management series. Again, today I have with me Dan and Tomas, and I think we're going to try to wrap up Yang today and get out of this Yang mess. So we'll take you through a few more examples, a few more CLI things, and then hopefully wrap this part of the discussion up. So with that, I'll hand it off to Dan to take us through.
Yep. Yeah. So hopefully this is a quick one, and everyone just loves Yang like so much. Like next time we'll go over like more transport stuff. So like this is the end of the boringness, I guess you could say, or the end of like the must need portion. So I'll go slides. All right, there we go. So here's kind of where we left off last, and what we're going to cover here today, which is generally going to be how do we make this work? Like where do we start? Which is the schema, which is what we talked about for like what was it, like 40 some minutes, I think, with Yang last time. So that was a schema we talked about. You basically get a schema. It's an open config, or it could be IETF and so forth. But it's a general Yang model and what you start with. And it kind of tells you what value should be. Today, we're going to talk about a couple different ways to actually take that and put some variables into it and actually render something good. We get a whole bunch of tools that'll let you do that. One's Ygot, one's Pyang. And we're going to focus in on those, and Tomas and I will both give some demos on both of them. And then once you actually have that, you create a data structure, which is the actual model of your device. So it'll have like all your BGP neighbors and so forth, and interface names and everything else with that. It'll kind of look like this. Like open config system is the model. So is the actual Yang model is system. It is configuration, hostname is CEOS1. Excuse me. And then lastly, next week, we're going to talk more about this, like how do you actually configure your device with it, like once you have it, or how do you actually pull data out of your device? And there's a couple of different transports that allow you to do that. But today is all about modeling. So it's more or less going to be how do you actually model configuration for your device. So here's what we're doing. We're taking a Yang model, excuse me, which simply looks like this. It'll say leaf hostname. What the type is, typically it's just a string, but you'll have things that are kind of like regex-ish. I'll take a link here in a second. And I'll tell you a little bit of the description about what it is, what it does, and that sort of thing. So if we click on this here, type domain name, you can see a pattern. It's really just a bunch of regex, but it's really just a regex that'll come out to be a host name, just like you would do on a switch, which would be host name CEOS, host name switch 1, host name switch 2, and so forth. But everything sort of has to have a type to it. I'll go back to this here, but everything sort of has to have a type to it. But what you need to do is actually take data, which would be the host name. So in my case, it's CEOS3 up to the right here, as we look here in red. And how do we actually render that? Like, how do we take Yang models, add some data to it, and then actually create a more or less a configuration, the modeling of our system? And that's typically where like your Pyang and Ygot come in.
So hang on that one. So let me just kind of back up for a sec. So the thing on the left, that's my Yang model. So that's defined in the Yang language as far as this is what a host name should be and what it should look like, as well as where it exists in sort of that tree that we showed earlier. Is that right? For like this leaf is off of a bunch of branches and ends up here for host name. And then on the right, what you have here is taking that host name, I guess, leaf node and populating it with something. So here you're actually taking that Yang model and putting it into use on the right with the JSON file.
Correct. Yeah, that's exactly it. So you basically have like your whole Yang schema language, whatever you call it, that just dictates like what a host name is, or let's say a VLAN has to be an integer, for example. And then you're taking data like you're saying, and you're pushing it together. And the switch itself, like this is a very small portion of it, obviously, but there's a whole big what's the word for it? A whole big open config model that describes everything that looks just like that in JSON.
And that model on the left is typically defined by either the open config group or by a vendor like us for anything that we have specific to Arista boxes.
Correct. Yeah, open config is like the most usual Yang organization, but you have open config, you have IETF, and then you have like ours, our Arista. than the proprietary ones.
So most users typically aren't messing around with the thing on the left. Like they're not editing that or changing that. They're really just consuming that and consuming it by creating the data structure you have on the right.
Correct. Yeah, they're going to use the tools because we as network people or automation people, we just need more tools. we need all the tooling, right? That's what we need. So yeah, let me down here so I can see everyone talking. But here's the tooling we're referring to. So this is Ygot. So basically what Ygot does is Ygot will actually take all your Yang models. So like we had host name before or host system before, and it'll basically take that and based off those Yang models, it'll create some Go importable code. So we'll have demos of this, but effectively what you do is like you'll go to grab a whole bunch of OpenConfig public models. And once you have those public models, it'll actually take the public models based off the ones you care about. You might care about all of them. I don't know. But once you actually do have that, it'll create like Go structs, Go interfaces, Go methods, and that sort of thing. And you actually create your file based off of that, off of writing code. It's pretty cool. Tomas and I will get into this. And the next one here is Pyang. So Pyang's practically the same exact thing. It's just that Pyang is in Python. Not to get into like the religious debate here between the two programming languages, but between the two, like Ygot tends to go a lot quicker than Python for obvious reasons. So this is typically what Ygot looks like. I have a link here, and before I forget, this open management site, which is all of us have really contributed to and built a lot of this. All the demos that we're doing today are going to be in here. A lot of information of running this will be in here as well. So there's some networks like github.io/open management. But Ygot can be found here. Ygot, obviously, a Google thing by Rob Shakir. Oh, I'm on Pyang. Whoops, using myself here. This is Ygot, and it kind of gives you a little description at the bottom, at the top of what it does. But basically, it just says in summary exactly what I talked about was take a bunch of Yang models and create like some Go structs so you can import a packageable code. The way this is done, they have a little binary called generator. You could either compile it yourself or you can run it just straight from Go. And my demo is just straight from Go. But that's pretty much Ygot. And they have some pretty good examples on here, I believe, in the, where is it at? It's in one of these example OC directory. Back to these slides here. So that's Ygot. But generally, you're going to run this generator, and you're going to give it some information. You're going to talk about the package name and that sort of thing. And you put the models in which you want. And then typically what you do is like, when you do have a separate piece of code, you import it. So OC, you got your whole Go path, whatever the module is in there. We'll explain a lot of it a little bit later. And we also have Pyang, which Tomas is going to demo. But effectively, Pyang is the same concept as Ygot, except for it just uses Python. So here's a basic example of how this works. You have Python, you do Pyang, and you turn it into JSON data structures. So Pyang itself is a binary. You pass in some information, and then basically you get this ocbind.py, and you tell it specifically which Yang models and what you care about. It's the same exact thing. And then what you do is you import it into code. So right here, import ocbind actually will import this into code. You can start messing around with it. It's weird because I kind of forget Python, but I think when you dir this out, this will kind of give you the different classes, I think. I can't remember, but you can see here, like once you dir OCBGP, is that how that works? I can't remember, which is weird.
Yeah, and it also gives you like what operations you can do with those.
Yeah, it's weird. I solemnly forget Python sometimes, but yeah, a lot of this information is here. You can see and the way this works, and just a link to it there as well. We talked about this before, but it's worth bringing this up. But Pyang is really good at linting, and it's really good at showing a human operator kind of like what everything is in the Yang tree. So like this OpenConfig interfaces and just kind of all the keys underneath it and what they do. So they read, write, config stuff and the state that you stream back and forth. But you just simply Pyang -f tree, which means it needs to see a tree look of this Yang model, and it just gives you a lot to look at as far as like for a operator's perspective.
So that was just actually just the output of running that command, and it's just going to dump out the Yang tree for you for whatever model you chucked in there.
Correct. Yeah. And it's good because like, because doing a lot of this, like writing code for this is rather difficult. And then compiling this every time you get new Yang models. And then also too, if you have issues, like, you're not getting a certain key that you thought you would. It's just, this is a really good debugging way of it. Yeah. You basically run Pyang. You point to some Yang or to a Yang file. And then effectively, like you'll kind of be able to lint and iterate, and not iterate, but lint and kind of look through what all the data looks like.
Does Ygot do this too, or is this just Pyang that has this feature?
I think it's just Pyang because and the reason why I say that is you get the generator binary, but I've never tried it with Ygot.
Okay.
Because just the Pyang one works so well for this.
Cool.
A bit of disclaimer as we kind of go through this. So OpenConfig in general, I think we've talked about this before, but it's used for streaming data, like streaming these Yang models. Most of the time, most people that I've talked to, and I say this, as a group we've talked to, typically just use this for streaming or gathering data. Typically, they don't use it for configuring things, even though today we're going to show you how cumbersome it is to actually configure stuff. It is difficult for the most part. It is complex. So typically with most customers, we see a whole lot of Ansible in some kind of data structure or some kind of data store, like whether it is CVP or whether it's Ansible and some kind of database or however it is. But most of it typically are not configuring things. So that being said, this is extremely difficult. Do not try this at home without without some OpenConfig supervision. We're not trying to scare anyone away, but once you get through a lot of these demos, like this is difficult. And it's not typically used a lot, but it's very good to talk about how this works.
Definitely lab this up before trying this out on your production network.
So let me stop sharing, and Tomas, you want to pick it up and shut it.
Sure thing. Let me just share my screen. Desktop 2. Having too many desktops. All right, yeah. So as Dan said, Pyang is a Python program that you can use to validate your Yang modules against RFCs and convert them. You can also convert them to Yin modules if you are using XML. And more importantly, you can use it to generate a tree representation of the models, and we have all these documented on our website. It's pretty easy to install it. You can just pip install it either with pip or pip free, and then you just need to git clone the OpenConfig repo from GitHub, and you can copy your Yang models to another directory, and then we can start it. So a few examples like this one, where it generates the tree for OpenConfig interfaces. If my Mac would work. Yep. Let me just go here. Oh, not sure why it's so slow.
Your terminal looks pretty good. Like, I like it.
Oh. Command T should open a new tab. All right, it does. So let me just go to the Yang models. And that should print the tree for the OpenConfig interfaces, just as you saw in Dan's slides earlier. And what is cool about it, it not only prints you all the containers and leaves, but it also tells you which keys are what type as well. So like, for example, the interface name is a string, or loopback mode is a Boolean, or description is a string as well, and so on.
Some
So
of those
it's
types are actually open config types I can see there, right? So like these are ones that the open config model defines, like that counter 64.
yeah, and then these have, if you open up the Yang files, you should see some pattern matching for all these. So it's pretty cool. And then you can also limit the tree depth. So like you can do something like tree depth equal 2. So it will only show the tree that to the depth you specified, basically.
Cool.
Oh, that's handy.
So it's a bit more readable if you wanna read only the hierarchy from one point above. And yeah, that's about it for Pyang. But more interesting demo would be showcasing Pyang Bind, which is a plugin for Pyang, which can convert the Yang modules into a Python class, and then you can use that Python class to build your JSON file to be able to configure your switches, basically, for any features. And as Dan mentioned, after you install Pyang Bind and again git clone the OpenConfig repo to get the Yang files, you can convert the Yang files to Python classes using Pyang, and this dash specifying the plugin directory, which would be in your side packages folder, and then you would create the Python file basically based on the Yang files. So in my example, which is this one, I've already done this because some of this takes quite some time. For example, the BGP Python file is like 43 megabytes. So it takes like up to 2 minutes. Well, depends on how much free RAM and how good your CPU is. And I generated some of these files. And the interesting thing is that if you look at the if you get like interface states or the BGP states, you will see that, for example, not only one Yang module is used, but there are multiple Yang modules. So for example, for SVIs, you would also need OpenConfig VLAN besides OpenConfig interfaces, or if you want to set the IP address, then you should also have the OpenConfig IFIP module as well. And you will also need some of the augments that we have, or depends on, even other vendors might require some augments to configure some things that are not in the standard Yang modules. For example, in up to 426, you would probably, in EOS, you would probably need the interface augments from Arista to specify that your IP address is a primary IP, but you won't need it in newer versions. So this is what I did as well. And in this demo, well, I'll be using the network instances in addition to the OpenConfig BGP Yang, and then the other would be for the interfaces, where I've used the OpenConfig interfaces Yang file, the OpenConfig-if-ip, and the Arista interface augments Yang. So just let me just
So do the tools
Sure.
give you any kind of warning, like if you try to use, let's say that BGP one, but you forgot to grab all the interface ones, like does it help you out at all with the dependencies that you
Yes.
have, or?
yes,
work.
yes,
Um,
but you can also generate, like you can also use these on their own. It's just that you won't be able to configure everything that you want. So if you want to configure a bunch of things, then you would probably have to mix these Yang files. Like, for example, if you only want to configure the interface description, then you probably don't need the IFIP Yang. But if you want to configure the IPv4 address or the IPv6 address, you would need the IFIP Yang module as well, and so on. If you need other things, then you have to check. Like, I think the simplest way, at least for me, is just to do a get on the path I'm interested in, and in the configs that I want to change, and then just check which Yang modules are used there, and then build a Python class from that. And so the first example is to very simple, just to create a description for Ethernet 1, apply this IP with this subnet mask, and add a description. So basically, after you have compiled your Python file, you can just import it like this. So for example, from OpenConfig interfaces, import OpenConfig interfaces, and then you can initialize your variable, and then you can add stuff to it and configure your interfaces. So for example, if I want to make this interface active, then you will have to set the enabled flag under the config key to true. Or same for the description, under the config, you have to, you can set your description. And then if you want to configure IPs, you need to use the sub. In this case, it would be subinterface 0, because that's the parent interface. And you would have to specify if you want IPv4 or IPv6. And then again, you can set your interface to be a routed port, which is no switch port on the CLI. You can do that under IPv4 config and setting the enabled flag to true. And it's interesting because some of these flags are actually strings instead of booleans. So when I was using like the boolean true with capital T, it was not doing anything. So I was like, am I doing something wrong? And then I had to check the actual type of the key. And yeah, it was weird. But hey, this works. So and then to configure the IP, you just set the IPv4 address under addresses address, and we also have to specify the address, which is a bit weird, and then your prefix length in the prefix length key. And as I mentioned, if you're using current EOS versions, you will have to also set the augment the type of the IP address, which in this case is primary, which is available in the augmented Yang module. And then once you've set everything you want, you can just generate your JSON file and then use any kind of tool like GNMIC to push your configs. So after running this script, Python set interface py.
And so should we imagine that it's going to treat it like a config replace kind of thing, or would it be treating it as an incremental config change? Like if I forgot to enable the interface, but it was already enabled on the switch, would it then disable the interface? Like or go to the default state of that particular piece of config?
I think it depends, but mostly it should use config replace, but also should use additions. Like I'll show you in a second where I only create a BGP neighbor. It will not actually touch the rest of the BGP config. It's sort of like using some sort of reconciliation in the backend. So it does not affect existing states, or it shouldn't. And this is the generated JSON file. So we can see here that I'm setting the IP like this and the prefix length, and then setting the augment type to primary, and the description up here. And so if I just run this GNMI command, GNMIC command, where basically I'm using the set RPC, and then I'm updating the interfaces path, and then using the interfaces JSON as the file. So that already has pushed the config. And if I check on the switch, I have a routed port with the IP and the description, which is pretty cool. And then the next demo would be to just create a BGP neighbor and set the remote AS for that neighbor, and then add a description. So I've added here two ways of doing it. One of them is just using the OpenConfig BGP YANG module, and the other one is using the network instance and the OpenConfig BGP modules, like here. And the reason I did this is just to demonstrate that you can also update or apply configs using one YANG module. You don't need to always mix multiple ones in one Python class. But again, it depends how many things you want to configure. Sometimes you will need it. And obviously, if you are just using, for example, the OpenConfig BGP module, then when you build when you're updating your path, you have to actually go down to the to that leaf reference, which I'll show in a second. Like running that script creates two files for me. So one of them was bgp.json, which is using the network instances and the BGP, OpenConfig BGP YANG. And then the other one is the bgp2.json, which is only specifically setting the neighbor itself. So you don't see network instances here, even though you know that BGP is is part of the network instances YANG. So for example, if I want to apply this, I cannot apply this just by specifying network instances as the root. I actually have to do it like this. One sec. So I have to go down until BGP here. Otherwise, it won't be able to apply the config, because it will complain that that leaf ref doesn't exist. So if I do that.
So these two things would do the exact same thing. It's just whether or not you are specifying where under network instances you're trying to modify in your Python file, or whether you're specifying it here when you're running your GNMI tool.
Yeah, exactly. And the other example would be much simpler because I can just specify the root tree, which is the network instances, and then it would apply my BGP config. So probably if you want to automate configuring your network with OpenConfig, you will want to create Python classes based on multiple Yang models, and then that is supported. I think did I want to show anything else here? Oh yeah, so we can see that it has here the description and remote I asked for that neighbor. And what else I wanted to show? Yeah, I guess later on I'll show the Cloud Vision stuff as well.
Cool. And so in theory, I mean, if you were really willing to go through the pain, you could skip using Pyang bind or Ygot and actually just handcraft this JSON. Right?
Exactly.
If you were really like didn't want to use those tools
Yeah.
and just were a glutton for punishment, you could do that. But if you mess up, a typo or, if that timestamp number was not the right format or whatever, you'd kind of be stuck. But all these are tools to take something more programmatic and then crank out the JSON at the end of the day.
Yeah, exactly. And this validates all the key values. So if you generate your JSON using Pyang bind and you write a Python script, then you will have less chances to mess up your JSON file. Like it should be it should be always valid, but maybe what you might be hitting is that sometimes you would forget to set some of the keys that are required for some of the configs, but usually you would get a complaint and a meaningful error if that happens.
Right. Which I think is actually one of the nice benefits of using something like a Yang model or an open config, where you're able to validate your data before you actually get further down the path, right? So that ability to kind of understand the types and what parameters are valid, is actually pretty useful.
Yeah, you got to think about like that whole enable equal true thing. Like, someone today could put a pull request into the OpenConfig, Yang models, set that to a Boolean today where it's a string, and then you can go to pull in some other Yang files or something that are mismatched different versions. It won't work. Right. So it's, why they're here.
Yep. So with that, I guess I'll hand it over back to you, Dan, to demo Ygot.
Cool.
Let me stop my sharing.
You guys see my screen?
Yep.
All right, cool. So this demo, just like the Pyang demo, in which Tomas just showed, can be found here. I think, where are we? We are under examples, Ygot. Everything's here. Kind of tells you what to do. Like, you can clone this repo and just kind of change directory into it. You do need Ygot itself to make this work. And same thing as Pyang, like Tomas just shown, like how you pip install it. Go is a little bit different. You just do the go get for the package or module, in this case package bit. You can kind of look at the output and then basically you run it. In the demo, I didn't compile it, just go run the go path where it's at, and you kind of push to what Yang models and what it's going to look like. And we'll just talk through the rest of it, and yes, good. But you can see that I'm in the open management repo inside here, and sort of how this works. Here's all the Yang models which I have. So kind of like before we talked about, like, you're gonna have to have everything and just the event that you want to import this. So basically what we're gonna do is we're gonna change a host name, like very simplistic one, very easy. but we need all of these in order to do that, which is rather unfortunate, but it's kind of the way it works. But we're going to import all of these. And that's the reason why this Yang directory has all of the Yang files. So we'll just get into and I just call it instructions here, but first and foremost, I am actually running CEOS as a container, how we're going to demo this. So just do Docker PS so we can actually see it. We'll just exec inside of it. And we are currently localhost. Let's pipe it up the list. So you can see we are running the gRPC, or the GNMI service that runs within here. So basically what I'm gonna do here is I'm gonna run this, and this will give me my good stuff here, which would be my Yang file, and should be relatively quick because it's Go, not a joke. But we'll see here. Like we're gonna get this OC.go. Yeah, I mean it's crazy. It's like Tomas, like when you ran Pyang, it was probably. I mean, I'm doing only a handful of these, but when you in Pyang, it was probably.
Yeah, it's slow, very slow.
Yeah, yeah. So yeah. Anyway, you're gonna get this OC.go, which is what I'm gonna generate. Well, what the generated code is from. So we could see here, like we have a whole bunch of Go code. Not really worthwhile looking at the code that I created here. I call this main.go, but effectively what's going to happen, and you can see like we pull it in here. So open management source, Ygot package, and it's called OC. But effectively what we do is you could see the, I call H, initialize H for the system struct. Come on. And down here, there's going to be a field called hostname. Come on. Yeah, let's actually do a bit of a split screen. VS Code is not working with me today. All right, so system struct. We have this little field in here called hostname, which is right here, and it's a pointer to the string. So we just fill that in with a bit of Ygot.string and CEOS1 is what we're going to call this hostname. And then from there, we initialize another struct called device, which is kind of up at the top, which then system, it points to system. And basically what that'll do is that'll create just a very easy string of CEOS1 on the model in the code here. But what you have to do is you have to marshal this first in just typical JSON. And the package you call it is emit JSON. But we're going to take D and we're going to marshal that against Ygot.emit JSON into this format and so forth. Basically in Go, if you do get it, you do get an error come back, it's going to tell you you have an error. Once we have this, we're going to say, hey, this is the output, and we're going to print this out just as a basic string, what it's going to look like. And then at that point, we're going to take the actual file. We're going to create config/hostname.json and put it there. We're going to close it out and write it. So let me just run this here quickly. Yep. So this is the output. And then I'll just throw it right in here inside config. Where are we at? Hostname.json. So it kind of looks like this. This is what I'm going to send to the switch. So I'm going to use GNMI binary to just kind of send this over. So before we looked at it, it was, let me just double check and make sure everything does work, which looks like it does. But effectively, here's what we're going to do. We are going to take this and we're going to just do just on the top amount. I just did a top root part of this, and we're going to do config/hostname.json, and this should just switch it over to CEOS. So let's exec into here, and it should be called CEOS1. And that is how that works. All that work for a hostname change. So this is really difficult and rather cumbersome. So you could have written some lines of Jinja 2 to make us work on something Ansible. And a lot of people are going to look at this and say that, and that is 100% true. It's just that this is multi-vendor. So like anything would effectively work on this as long as it supports a Yang model, Yang tree with all these models and GNMI and everything else. This would configure hostname across everything. Where obviously in Jinja or anything else, you'd have to have like a lot of templating and decision making and that sort of thing. But all this demo is up on our open config management site and so forth.
So, yeah, I mean, I think you hit some of the things. Why would you go through the trouble? I think the multi-vendor aspect is nice, right? You can do it once and it'll work across different platforms. I also think some of the, I'll call it type checking is nice, where it's going to make sure you don't go out of bounds when you're putting in, I don't know, putting in a VLAN number that you're not putting in VLAN 10,000 or something like that. So some of that type checking is kind of cool too.
Yep, and just the last thing I'll talk about is like once you actually do have that JSON file, like this is what I've seen. A lot of places I work with, like typically people will take that JSON file and they'll version control it in some form and Get obviously, and it kind of expose it with the RESTful APIs. Typically, a client, something will actually reach out and grab that model information and so forth.
That's an interesting point. So what you also could do here is you could generate these JSON files independent of, you know, someone who actually needs to do the configuration, right? So you could try to reduce the amount of churn you have to do where you're running this thing every time you want to make a little change. Maybe there's a way to version control, as you're saying, the JSON files and manipulate those.
That's possible. So yeah, cool.
Okay, we had a bit of a laptop malfunction last time. So what we're gonna do is just pick it up from here, from this slide. And I think we left it off where we were talking about how Cloud Vision can actually act as a gateway for connecting your OpenConfig and Yang stuff into the other switches. So Dan, you want to kind of explain what's happening here on this slide?
Yeah, so we'll talk about CVP a little bit. We talked about this slide about how people mainly use this in the open source world of connecting and modeling and everything else. But we have a new feature that's out in our brand new version of Cloud Vision portal that actually allows you to pull streaming data through gRPC of all the Yang models just through a single IP entity. So that IP entity would be Cloud Vision, whether it's in our Cloud Vision in the actual cloud and our CVAS or SaaS solution, or on our on-prem devices. It's actually very neat. So the way it works is that you stream all your data with our streaming agent, we call it Terminator, and that data actually lives on CVP. So it's live, streamable, and any change delta, that data is actually there. The way this new feature that Tomas is going to demo is that you could take external clients through GNMI and actually pull all this data like rapidly, like quickly over streaming data. So any third-party integration tooling can just point directly to Cloud Vision and pass in what's called the target flag. The target flag essentially says target my leaf device, leaf A, target leaf B, target leaf spine, and so forth. So it distinguishes between how you pull the data, and you just separate a path. So let's say, for example, common use case would be, I'm an external tooling and I want to pull all the interfaces off a certain device and I want it to stream back to me. So I get all the interface counters. And the neat thing is that you're just asking a single device and you're doing it over a standard gRPC protocol with the standard GNMI service. I know that's a lot of word salad there to take in, but it's very, very neat. And Tomas is going to show that here. You want to start to share?
Sure. Let me start sharing. I think you'll have to stop sharing.
Yeah. Okay.
Just a second. All right. So you guys can see my terminal.
Yep, all good.
Awesome. So I'll show a few examples. One of them is, for example, how to subscribe to interface counters for a switch. And as Dan was mentioning, our GNMI address would be Cloud Vision itself, which in my case is 1083.12.174 on port 8443, which probably at some point will change to 443. And in the cloud service, it's actually 443 already. And then you can specify if you want to subscribe or get, which actually even the get is a subscribe, but when you want to do a single one-shot get, then you would have to set the mode to once, and then still use the subscriber RPC. And then you specify the path as you did previously. Specify the origin, which is OpenConfig in this case, and then supply token. You'll only be able to use service account tokens, which have been around for a few releases now, and you can generate those from the UI. And then, as Dan mentioned, you will have to specify your target, which is your serial number. So if I'll kick this off, it should subscribe to the interface counters, and we can see how data is getting pulled in, which is pretty cool. So this is all real time.
So the
Yep,
cool
it's-
thing with this is
oh.
now I could use the same exact thing, but replace that target with a different switch's serial number and get the counters from that one, right? Basically, any
Yeah,
switch
exactly.
that's subscribed into CloudVision now, I don't have to go reach out to that switch individually. I can just hit them all through one place.
Yep.
Yeah, exactly. If I'm now removing that and choose another switch, then again, it works fine. So it's pretty easy to like programmatically get all these, like get the inventory and then subscribe to all of these switches and the path that I'm interested in. Another example would be, for example, you can also use RESTconf. So if I want to do the same, then again, it's the same as you would usually use RESTconf as before, same path notation as well, but you have to add some query parameters and you have to specify the Arista target and the Arista origin, which for now is just OpenConfig, but at some point it could also be other origins. And then, as you can see, you can get you can also specify the interface names or any other key value that that you used to before. And then you can see how that counters are incrementing on subsequent send requests. Another cool thing, what I wanted to show just to demonstrate that this is happening real time is in this example, I'm fetching the prefixes received from one of the neighbors, which is using IPv4 unicast as the AFI SAFI in BGP. And currently this interface is down. So obviously I have 0 prefixes received. And as soon as I unshut the port, I should get prefixes already, and here as well. Oh, sorry, that was on another device. This try to be sorry. And we can see that it has established 15 seconds ago, and we got the prefixes. So it's pretty. It's very cool, and you can use any kind of GNMI client as well. As you saw, we use GNMIC, and for RESTconf you can use curl or Postman. And what else is really cool, which I like about CloudVision, is that since all this data is already stored in CloudVision, you can go to the settings page and the telemetry browser and select your device. Then you can see all the OpenConfig data that we stream from our switches. For example, if I want to see the same prefixes received, I can just go to that path. So network instances, network instance, the VRF name, protocols, protocol BGP, BGP again, neighbors, the neighbor address, AFI, SAFI, and then select whichever you want. And then you go to the state, and you can then see your prefixes sent, received, installed, best path, best TCMP path. So it's pretty cool, and you can do this for all your devices.
You want
and
to
obviously,
one flag, the needed flag on Terminator real quick?
yes, yeah, that's a good point. So to make this all possible, you would have to be running on Terminator 1.13.0 or newer. And you will also have to add a new flag, which is called CVGNMI. So essentially, your configuration should have that flag, this one. And once you add this, the switch will start streaming OpenConfig data model as well. And in the future, this will be a default, like we will stream OpenConfig by default from the switches. And also, in addition to that, we'll keep streaming the EOS native paths, as not all paths are converted to OpenConfig models.
Very cool.
Cool. Yeah, this is such an awesome feature. Like I can't talk about it enough. Like we'll go, next time we talk more about transports, but just to think about this, like you have all the data and you expose all the data in a service and which is open that everybody knows with GNMI. Like that's like just so awesome. So good demo.
Yeah.
Yeah.
And we also have Yang in CVP now, but in the beginning, we will only support inventory path. So you'll be able to get the inventory from CloudVision using GNMI again. And you can also check that in the telemetry browser. So if you go to analytics, you have Yang and Arista, and you'll see a few Yang models here. There's inventory and segmentation model config epoch, which is for integration with Forescout for zero trust segmentation. So you'll be able to fetch your inventory using GNMI as well.
Yeah, so this is actually kind of handy as a Yang / OpenConfig browsing tool too, because I know someone like myself,
Yeah.
I might not know exactly what the path I need is. And so this gives me a way of kind of figuring out exactly what I'm trying to grab.
Yeah, it's pretty cool.
Cool.
Much better than the HTML explorers that are out there.
Yeah, totally. And the nice thing is after you've drilled down into this, you can actually see the stats here. So you know you're getting the exact thing that you want. Now throw that into your command line or whatever you're doing. And then now you can fetch it.
Yeah,
from then
super.
on.
Yeah.
Super awesome. Like I hope more external tolling take advantage of this, like, cause it's really good. I mean, but the bar is set at SNMP, so anything.
Yeah, and this is the other cool thing. Like you can actually see this real time increasing, so
cool.
it's amazing, and it says last update as well. So.
Oh, cool. Yeah, I've seen the unicast packets. Yeah, I didn't know that was there. I didn't know I did that. That's super neat.
Yeah, it's just I don't have too much traffic, so it's only incrementing like 100 bytes at a time or so.
Sure.
That's cool. Yeah, that's awesome. I didn't know it's automatic refresh. Yeah, that's cool.
Very cool. All
Cool.
right. Well, I think this has been a pretty long one again, but I think fortunately we can wrap up Yang and move on to some other more fun stuff. Any kind of closing thoughts on Yang in general? I think from my side, I picture it as you're not likely to actually write your own Yang models, probably, unless you're a provider or something like that who's actually authoring OpenConfig models. But you do want to understand what it is and how it works so that you can take advantage of them as a consumer. And the other thing I think I gleaned from this is you're probably going to use it mostly for monitoring and read-only. Using it for config is kind of gnarly and not really what most people are using it for.
Yeah.
Yep. I think that's a good group to think on that. I think we all are in agreement to that.
Awesome. All right. Well, appreciate the time, guys. And hopefully this is useful to folks. And I think next time we'll dive into the transports a bit more. So we'll record another one in a few weeks.
Cool. Awesome.
Cool.
Cool.
All right.
Thanks.
All right.
Thanks, guys.
Thank you.